What is special alloys? Yeah, special alloys, it's not a, you can say, it's not a perfect definition. That's not an international standard saying that a special alloy is like this and like this, but it depends all, you can say, where you come from. If you're in the stainless steel world, then you will regard the special alloys as a very high alloyed stainless steel, and also the nickel molybdenum, nickel base, nickel chromium molybdenum, nickel base alloys, because they act, you can say, as a natural extension of the stainless steel. Corrosion, unfortunately, stainless steel should be stainless. It's not. You can suffer from, the steel can suffer from all kinds of corrosion, which could be general corrosion, pitting corrosion, crevice corrosion, and so. And normally the way to deal with this is to pick a stainless steel with a sufficient amount of chromium and molybdenum when you talk about pitting and crevice corrosion, and nickel if you talk about general corrosion, and thereby try to avoid or perhaps minimize the corrosion problem. For instance, this flange is so clearly suffering from crevice corrosion. It's a so-called acid-proof stainless steel, which definitely proved not to be that proof. And you see the crevice corrosion here, which is the result of being immersed into a tube system, a pipe system, handling high chloride sewage water. It's not a very good idea. Sometimes the steel may suffer from general corrosion, like this piece, which is what's happening if you immerse the steel into strong nitric acid along with hydrochloric acid, aqua regia, or hydrofluoric acid, that's in the pickle, or in this case, sulfuric acid. This gives you more uniform attack, and in this case, it's all about having a high molybdenum and a high nickel content. In the upper end of the stainless steel, if you want to fight both types of corrosion, we have the 904L, or the 4539, which is, among other, this piece. It contains 20% chromium, 4% molybdenum, and a whopping 24% of nickel. And this gives it a very good resistance against virtually any type of corrosion. But still, sometimes this is not enough, and then what do? Then you add a little more chromium or a little more molybdenum. In this case, 2% extra molybdenum, and we have the 6 molybdenum austenitics. These 3 samples, all pharmaceutical fittings, I have to say. And in these alloys with about 20% chromium, up to 25% nickel, and 6% molybdenum, we get a little extra corrosion resistance. But then we can also see that the amount of alloying element is so high that now iron begins to be less than 50%. And then it's not regarded as a stainless steel anymore. It doesn't change anything regarding the, you can say, the chemical performance, but it would just start naming it nickel-based alloys. If we add even more chromium, even more molybdenum, as we do with the alloy C22 and the alloy 59 over here, then suddenly we end, for instance, the alloy 59. We have an alloy with 15% molybdenum and 22% chromium, and there's a maximum of 1.5% iron. So of course it's not a stainless steel anymore. We call them nickel-based alloys, but the mechanism is exactly the same as a stainless steel. A lot of chromium, a lot of molybdenum to maintain the passive oxide film. Then there's one group of nickel-based alloys which are they don't come from the stainless steel. But that's the high temperature alloys, and this is a very fine example. It's one called Inconel 600, and it contains more than 70% nickel, only 15% chromium, no molybdenum. High temperature alloys is usually without molybdenum, and then just very few percent of iron. And this one has, the reason this one, which is the same as this one by the way, is good in very high temperature is because the creep strength is very high. It doesn't get soft the same way as most stainless steel types do when you get to very high temperatures like 600, 700, 800 degrees. It maintains its mechanical strength. So the reason for this chromium nickel alloys is not that we want to have a terrific corrosion resistance, because it doesn't. But we want to have the mechanical strength at a very high temperature. So all of these ones, some you would one way or the other call special alloys. A lot of families, some made for corrosion, some made for high temperature, but it's all special alloys. The negative side, they're bloody expensive. We have to admit that. The stainless steel among the special alloys are the cheapest one, or the least expensive. Once you go to the pure nickel base alloys, we are much more expensive. But still, it's cheaper than having a complete breakdown in a production factory. So, it's worth considering.